Before we went over the homework, I covered a bunch of these facts you already knew. All right. I also thought of a couple more that we didn't review yesterday, so I want to do those. You don't have to copy down a thing because I put all this stuff on Classroom, and I'll show you why in a second, and that's why you have your laptops out. So let me go over some things I did not approach yesterday. Algebra. You might see something like this tomorrow. Let's say it's part of Pythagorean theorem on a problem. You got to do Pythag to find a side, maybe. So you do x, I don't know, x squared plus x minus 3 squared equals 6 squared. That's what it ends up being. My concern is, are you going to know how to handle that? Okay, every time it comes up this year, I always have a worry. It's not x squared minus 9, right? It's not x squared minus 9. I rewrite it twice, and then are we comfortable double distributing here and combining your like terms? Okay, so I just wanted to make sure we were going to handle this correctly tomorrow if it came up, which it will. All right, we're okay there? All right, some other circle facts that I want to review, including yet the ones I gave you yesterday. Here we go. And again, you don't need to copy anything down because you'll be amazed at what I put together here in a second. Angle Q, how do I find it? Use the arc names, please. Use the arc names. How do I find angle Q here? 5.
Half of arc SU minus arc TR.
There you go. Major arc in between minus the minor arc in between. That was the main concept yesterday. Good work. Thank you. Stop me at any time here. Angle XWV. Angle XWV. We just spent a long time reviewing that on homework. XWV. How do I find that angle? Go through your head too. Inside, outside, tweener. What's the deal? How do I find that angle? 19? Good. It's a tweener formed by a chord and a tangent, which you have a rule for. Half of XZW. Yep. Chord and a tangent. I have a rule. And then what about over here? Angle ABC? Angle ABC up there? How do I find ABC? 7? Why confusion? Darn right. There is no rule. Why? It's a tweener formed by a, what's ABD? Secant and CB? None, right? None. So, but I will ask you to find it, right? So how to find it? I'm going to do 180 minus angle CBD, which is what type of angle? Inscribed. Okay? So no rule there. Please know the difference between the two because I don't need you taking half of arc BC here. That's not the rule. That's only for tangent and a chord. All right. I'm just going to throw this up here. Give me a statement and a reason why your statement's true. That's circle B, by the way, circle B. And I don't want the statement to be AC is a chord. Like this is something you'd write in your proof. All right, something you would write in your proof that's useful. What could I say in the statements and why? What's true about my diagram? 9?
AB converted to BC.
There we go. I definitely write that down. AB. Why is that true? False.
In a circle.
In a circle, they all are, yes. Not every single radii. So yes, make sure we got that bad boy in there. All right. Oh, waiting for, I totally forgot about this yesterday, but it is going to be on the quiz because it was part of day 5 through 11. What's true here? I'm going to put 2 things down I want. 2 true facts and why. take a peek at my diagram. What's true about that diagram? And those markings are all given. So please don't tell me what's given. Whew. What is true here? Just one true fact if you got one. 23.
EF is congruent to AB.
All right, there we go. Chord EF is congruent to chord AB. That is true. Why, Maddie?
Because chord is equidistant from the center arc.
Woo! Perfect. Chords equidistant from the center are congruent. Good work. One more fact. Yes, the chords are not. Don't tell me. I know if the chords are equal to the arcs, I'm not looking for that. I'm just looking for this right now. Just given this diagram, what else is true? Nine. Hi. Anything? I'll push you towards it.
AD congruent to DB.
Not yet. You can get there, but not by the theorem, though. The theorem's going to tell me what? CD.
Bisects AB.
That's what I'm looking for. CD bisects AB. And then in step 3, you could say definition of a bisector. But, all right, you remember why that's true?
A chord.
Oh, no. CD is part of A.
A radius perpendicular.
I'll take radius. I'll also take diameter. Go ahead. Perpendicular.
To a chord bisects it.
There you go. Nice. Bisects the chord. Good work. Nice. All right, all good? Okay, open up your Chromebooks. Please go to our classroom page. I want to show you why I didn't have you type anything in. Just quickly go to our classroom page. Look for Unit 10. So make sure you go to Classwork, Unit 10. And you'll see a nice little file there that says Theorems and Facts for quiz number 2. And if you open that up, it's everything neatly written out for you, diagram along with fact. Okay? So I can lead you to it, but I can't help you absorb it. That's on you. Okay? That is on you. So does everyone see that? Go back to classroom, Unit 10. I also want you guys to see, hopefully it's there. It was there, period 7. You guys have the king size circle problems there? All right, there's 46 of them there. All right, if you want some extra practice. The answer key is after the 46 of them. Okay, so that's all there. All right, so go back to all the facts and theorems for me. Please go back to that page. You're going to leave that open because we're going to do a king size one right now together in your packet. And then you're going to go on your own. So you may need some of those facts to look up real quick. All right, so please go to number 7 in your packet for me, number 7. We'll do one together. This is probably, I picked this one because there's a lot of challenges in this one.
Bless you.
All right, label everything you can. Go ahead, label everything with the givens there. Number 7 in the review. Label your diagram with everything I've given you. 2 arcs and an angle. All right, here we go. You know how I roll. I don't even look at what they're asking me. I don't care what it is. I want to find the arcs if I can. Find as many arcs as you can. Sometimes you may not, and that's okay, but find as many as you can, and in this problem, you can find all of them. So go ahead. If you want to talk it over with your group, go ahead. Can I find the 2? There's 2 more remaining arcs that I do not know the measure of. Can you find the measure of those arcs? You Should be able to, if you know your facts, right? Find the measure of the two remaining arcs so we can go to town.
Oh, yeah.
All right, here we go. You had to find them in a particular order. You had to find arc EA first. You had to find that one. So arc EA, how'd you get there? 21, how'd you get to arc EA?
EA.
EA. Because I couldn't find DC unless I knew EA. Look at the angle 75 I gave you, Dan.
Yep.
Inside?
Yep. No.
Outside?
No.
Tweener?
Yep.
Okay, what's AF? That's part of A?
AF. That is part of a tangent.
And EA?
EA is a chord.
So we got a rule for that, right?
Yep.
How do you find a tweener angle that's formed by a chord and a tangent?
Oh, is that okay?
That's what?
Is that the no rule one?
No, that's secant. This is tangent and a chord, so we'll get there.
1/2.
1/2 or whatever the arc was.
Mm.
So if my angle's 75, how do I get back to the arc?
Double it.
Okay. What do you got for me? Oh boy. Now we're moving.
150.
All right, you got it. Good work. Now that I know that's 150, now I can find the remaining arc. How? How can I find the remaining arc up there? 25?
Add all the other arcs you have.
And?
Subtract 260.
Okay, I should get 70 here. All right, you ready for give me a little help here? AE. Arc AE. Oh, that's done already. I don't think I need to call on anybody there. 150. All right, DOC. Angle DOC. 12. DOC. Inside? Central. Yeah, whoa! Look at that. That's usually a no. It's a central angle. Ooh, we got to dig deep. What was the rule for the central angle? So this is going to be 70. Throw the darn angle in your diagram. You may need it later. OAB. Oh, now we get fun. Now it's going to get fun. 10. Ready. OAB. Inside?
No.
Outside? No. So it's a tweener. But watch what happens here. And this is why I picked this problem. Ready, Zach? What's BA? Part of that angle is a what? BA is a? Tangent. What's the rest of it? OA. That's no tweener angle I'm familiar with. Right? Because we need a chord at least. This is nothing. It's nothing. I don't know what type of angle this is. I don't have a name for it. I'm not going to make it up. So if there's no name for it and there's no rule, probably there's another circle fact I'm not thinking about instead of a formula. What was OA again, Zach? Drawn to? What happens? Magic happens there. Magic happens. Let me say it again. Magic happens. Radius drawn to a point of tangency. Forms? Done. There you go. So if it's not inside, outside, or a tweener, we got to think of something else in the circle family. All right, let's keep moving. OAE. It gets even better. Gets even better. 10, Zach. No, I'm not going to put you through that again, or us. 25. 25. Here we go, James. OAE. Inside.
Oh, yeah, sorry.
The angle's inside. So watch this, everyone. Watch. Is it central? No. Is it inscribed?
Yeah.
No.
No.
No. Even though most of your classmates are saying, what? It's on the circle. Why is it not inscribed? Definition of an inscribed angle. Yes, the vertex is on the circle, but the other two sides have to be chords. They have to be chords. OA is not a chord. So that's not an inscribed angle. So how are we going to find it? I don't have any circle rules. Better use some geometry now.
Add 75 and 90 and subtract from 180.
This forms a straight line. Those three add to 180. Or you know angle OAF is 90, and that's already 75, so do 90 minus 75. All right. So, hey, look, are you starting to see that a circle fact isn't going to bail you out every time? You might have to do some old school Unit 1 geometry. 15 degrees. Good. Oh, and then we get to the challenge. If you haven't been smacked around yet, now it will come. DCO 28. Tyler, you ready? Inside?
Yes.
Yeah, it is. Central.
No.
Inscribe.
No.
No, our definition we just went over. It's got to be 2 chords. OC is not a chord. Floater?
No.
Nothing we've talked about. Nothing. So we better rely on some either circle facts or some geometry here. Ready, Tyler? What's OC?
Radius.
And how about OD?
Radius.
And they're in the same circle.
Congruent.
Darn right they are. Now let's go back to Unit 4. What type of triangle do I have there?
Isosceles.
What's across from the congruent sides? There we go. Welcome to the little honor circles there. So 180 minus 70, cut that in half because those two are equal. 55 degrees. Woo-hoo! Again, the purpose of doing this was say the circle fact may not always bail you out. All right? All right. You are on your own here. Pick your poison where you want to go. There are plenty of oh, and just so you know, all the answers to your problems here are further along in the packet on page 45. Okay, page 45. 1 king size problem tomorrow, 1 proof is on there tomorrow. And then the rest are all like little circle fact questions. All right, but 1 proof and 1 king size problem. And if there is any good news, that's the last proof you're going to do until we review for the regions. We're done. All right, no more proofs. All right, no more proofs. What's up, Brody?
What do I need to find?
The hole there?
Yeah.
Yeah, sure. Let's find out what you have to find there.
Measure angle B.
PDF circle packet. What page you on there?
We're on.
40.
I can't see that.
It is 40.
40?
I just had
It's angle B.
Yeah, I had
That's my fault. My fault.
Yeah, it is your fault. Do you want it?
What number?
It's a top page. It's angle B.
I already solved the problem.
Yeah. Okay. Oh yeah.
I'm already here, so I'm finishing the job.
Page 40. Yeah.
Find angle B.
The answer's 40.
Angle V?
Yeah.
Okay. There we go.
There you go.